Question is, a bit stream 100 is transmitted using standard CRC method. Okay, the generator polynomial is x cube plus x square plus 1. What is the actual bit string transmitted? Also check whether the data is accepted or not. Fine, so we have to perform all the operations from sender to receiver. So you can see in this case the message is 100. The generator polynomial is x cube plus x square plus 1. So you have to convert this into binary. So how to convert? So if the term is like it is a polynomial, so it should be x cube plus x square plus x plus 1. So you can see here x is missing, so the coefficient of that x will be 0. And whoever are present, the coefficient will be 1. So 1 into x cube plus 1 into x square plus 0 into x plus 1. So we can ignore this variable part and only the constant portion is written. So it is 1101. So this is n bit. Fine. So the first step was we have to append n minus 1 zeros to original message. Okay. So it is n bit. So n means it is 4 bit. So we'll append n minus 1, that is 3 zeros to the message. So this is our message 100. We'll append 3 zeros from right side to the message. First step. After that we'll go to sender side. Okay, so you can see in sender side we have divided, this is our message. After appending 3 zeros, we are dividing it by generator polynomial, which was 1101. So we are doing XOR operation. So you should know what is XOR operation. In XOR operation, if there are similar bits 1 1, the answer is 0. If there is dissimilar bit, the answer is 1. So you can see 110, 011, 000, 110. Okay, so in this way it is divided. If it is 1, so it is 1101. So again the remainder is coming. So again by 1, again by 1. So it has been divided 1111 4 times. Okay, so again if we'll divide this by either 0 or 1, we'll get same answer. We'll get same remainder repeatedly. That's why we come to know this is the remainder. So now what we'll do? What was our remainder polynomial? What was our appending number of zeros? It was 3. Okay, it was n minus 1, that is 3. That's why we'll take 3 bits from right side, that is 001. Okay, how it is taken? The number of appending zeros are n minus 1, that is 4 minus 1, which is equals to 3. That's why we are taking 3 bits from right side. So it is 001. So our CRC bit is 001. Now the transmitted bit that sender is transmitting to the receiver, it will be original message plus the CRC bit. So original message what? 100 plus 001. So in other way we are replacing that 3 zeros that we appended with our CRC bit. So now this is called our code word. Message plus CRC bit, that is called code word. Finally, this code word is transmitted to receiver. So you can see here again we are dividing this code word with our generator polynomial. So same way we are doing binary division till the point we are getting a repeated remainder. We'll do the division. Okay, so at the end you can see the remainder is 0000. So the data is accepted. It means that there is no error. Okay, so this is the case of a CRC numerical. So if you have any question, you can ask me in comment box. Also, if you want me to make another video tutorial on CRC numerical, just comment in the YouTube video tutorial and I'll make another video on CRC numerical. And if you want the note for this particular portion or this particular video, so you can comment me. Okay, so till then stay safe and like, share and subscribe our channel. Thank you.